Welcome to the Network and Cybersecurity lecture series. Myself, Darshan BD, Assistant Professor, Department of ECE, SJB Institute of Technology, Bangalore. The Network and Cybersecurity subject code is 17EC 835. This subject is professional elective for 8th semester students. In this subject, we are going to study the network security concepts and also a cyber security concept. It consists of 5 modules. First 3 modules covers the network security concept and another 2 modules covers the cyber security concept.
Encryption and authentication algorithms. The payload data, padding, pad length, and next data fields are encrypted by the encapsulating security payload service. The algorithm is used to encrypt the payload, requires cryptographic synchronization data such as an initialization vector. Then these data may be carried explicitly at the beginning of the payload data field. If included, an initialization vector is usually not encrypted, although it is often referred to as being part of the ciphertext. The ICV field is optional. It is present only if the integrity service is selected and is provided by either a separate integrity algorithm or a combined mode algorithm that uses an ICV. The integrity check value ICV is computed after the encryption is performed. Note that the ICV integrity check value is not protected by encryption. A key integrity algorithm must be employed to complete the integrity check value. So this is the encryption and authentication algorithm. Padding. The padding field serves several purposes. First point, in an encryption algorithm requires the plain text to be multiple of some numbers of bytes. Example, multiples of single block for a block cipher. The padding field is used to expand the plain text consisting of a payload data, padding, pad length and next data fields to the required length. The ESP, encapsulating security payload format, requires that the pad length and the next data fields be right aligned within a 32-bit word. The cipher text must be an integer multiple of 32 bits. The padding field is used to assure this alignment. Additional padding may be added to provide a partial traffic flow confidentiality by concealing the actual length of payload. So this is the padding we are going to do for the alignment and we are going to match with the format. Next is anti-replay service. So in that, consider a replay attack is one in which an attacker obtains a copy of an authenticated packet and later transmits it to the intended destination. The receipt of duplicate authenticated IP packets may disrupt service in some way or may have some other desired consequences. So consider the anti-replay mechanism. The sequence number field is used throughout the replay attack. So in that you can observe that the marked if the valid packet is received and we are going to consider so unmarked if the packet is not yet received, that is the shaded one is a valid and the white one is unmarked, means then we are going to consider the fixed window size. The window size you can consider as W advanced window if valid package to write is received. Here we are going to consider the starting with the n minus w, that is the packet n plus 1 packet we are going to consider. Here the sequence number is set to 0 with a new security association established. The number is incremented by 1 for each packet sent to security association. Once each packet is sent, we are going to check that we are going to send it into security association, that we are going to increment that. The security association is terminated or negotiated with a new key is n is equal to 2 power 32 minus 1. Here we can consider the window size. The window size is W is implemented in order for the IP packet to be delivered in a reliable manner. The right edge of the window represents the highest sequence number, that is n, so far received for valid packets, that is n. So for any packet with a sequence number in the range of n minus w plus 1, they are from this to n, so this range that has been correctly received. Okay, the corresponding slot in the window is marked, that we are going to consider that. Here you can see that it is in the rectangular box. The sequence number is set to 0 with a new security association established. A window of the size W is implemented in order for the IP packet to be delivered in a reliable manner. Right edge of the window represents the highest sequence number n, so far received for a valid packet. Transport and tunnel modes. Here we are having two modes of operation, transport mode and the tunnel modes. Two ways in which the IP security ESP service can be used. In the upper part of the figure that we are going to consider, encryption, that is optionally authenticated, is provided directly between the two hosts, so that we can see in the figure. Here this is the transport level security. Here the upper part that you can observe here, this is the encryption is provided directly between the two hosts, so that is called encrypted TCP session. Otherwise we are going to consider the internet network is there, or internal and external networks. So through that you are going to connect it to the computers. That okay, in that, so we are having, so encrypted TCP direct connection will be established between the two end users. You can observe this figure, transport mode versus tunnel mode encryption. See that transport mode and tunnel mode encryption, considering the virtual private networks via tunnel mode. Here the corporate networks are interconnected across the internet. There the corporate networks are connected to the user end and host. Here we are going to consider the encrypted tunnels carrying the IP traffic. So here the corporate network to corporate network direct connection will be established. Then so we are going to communicate to the other user, that is encrypted tunnels carrying internet protocol traffics. By terminating the tunnels at the security gateway to each internal network, so here the configuration allows host to avoid implementing the security capabilities. Here we are going to consider the former technique is supported by the transport mode security association, while the later technique used for tunnel mode security association. Considering the example, an organization has 4 private networks interconnected across the internet. Hosts on the internal networks use the internet for transport of data but do not interact with other internet based hosts. By terminating the tunnels at the security gateway to each internal network, the configuration allows the host to avoid implementing the security capabilities. The third point, considering the warmer techniques, is supported by a transport mode security association, while the later techniques uses a tunnel mode security association. Here we are going to consider the scope of the two modes, considering the transport mode and the tunnel mode. So here we are going to use different internet protocol versions, so IPv4 and IPv6. The scope of ESP for two modes, the consideration are somewhat different for IPv4 version and the Internet Protocol version 6. So we use the packet format. So considering the figure, so it can show that before applying the encapsulating security payload, so for the Internet Protocol version 4, we are having original IP header, then the TCP transmission control protocol, then followed by data. Same thing if you consider the IPv6 version. So Internet Protocol version 6 gives the extension header. Consider the original header part, TCP and data, but we are going to get the extension header in Internet Protocol version 6. The algorithms and parameters for two suits as with RFC 4308, three categories of secret key algorithms are listed. Concerning the encryption, for ESP, authenticated encryption is provided using the GCM mode with either 128-bit or 256-bit AES keys. For Internet Key Exchange encryption, CBC is used as it was for the VPN suits. Message authentication, for ESP, if any authentication is required, then GMAC is used. So that we are going to discuss. For Internet Key Exchange, message authentication is provided using HMAC with one of the SHA-3 hash function. Pseudo-random function, as with the VPN suits, Internet Key Exchange version 2 is in these suits generates the pseudo-random bytes by repeated use of the MAC used for message authentication. Consider a transport mode and tunnel mode functionality. So in that, consider a transport mode security association and tunnel mode security association. For that, we are going to consider the parameters are AH is authentication header, ESP encapsulating security payload, then ESP with authentication. In the transport mode security association authenticates IP packet and selected portion of the IP header and IPv6 extension header. So as we discussed that in the transport mode, authentication header authenticates the payload. Payload is nothing but data, and selected portion of the IP header and IPv6 extension header. Similar that we are going to consider the authentication header in the tunnel mode security association. It authenticates the entire inner IP packet, inner header plus IP payload, entire packet. The packet consisting of the header and the payload, plus the selected portion of the outer IP packet header, selected portion of the outer IP header and outer IPv6 extension header. That also is going to be considered. Consider the second parameter is ESP, encapsulating security payload. So it will encrypts IP packet and any IPv6 extension header followed by ESP header. So consider that the encapsulating security payload for transport mode security association, it encrypts IP payload and any IPv6 extension header followed by ESP header. ESP means encapsulating security payload header. In the tunnel mode security association, that for encapsulating security payload, it encrypts entire inner IP packet. It's going to encrypt entire inner IP packets. So it's not going to consider the outer header part. So inner IP packet consists of inner IP header and also IP payload. So coming to the ESP with authentication. So both authentication header and ESP encapsulating security payload. Here we are going to combine ESP with authentication. It encrypts IP packet and any IPv6 extension header followed by ESP header. Because we know that the IPv6 provides the extension header, so that we are going to consider that encrypts the IP payload and any IPv6 extension header followed by the encapsulating security payload header. Here encapsulating security payload having the header and a trailer part also. Authenticates IP payload but not IP header. So it's going to authenticate the IP payload but not IP header. So encryption and authentication both are coming to picture. So it's going to encryption is happens, but authentication is not happen for the IP header. In the tunnel mode security association, that for ESP with authentication, so it encrypts entire inner IP packet, authenticates the inner IP packet. So it's going to encrypt the IP packet, inner IP packet, and authenticates the inner IP packet. Okay, both it will be happen that. So encrypt inner IP packet, authenticates inner IP packets. Both will be happen in the tunnel mode security association. Thank you.